Hello everyone, and thank you for watching this video. My name is Bleynat, and I'm a PhD student of the 36Cycle, and I'm working on the topic of Monte Carlo modeling and variance reduction technique applications for decommissioning, generation for nuclear reactors and fusion systems under the supervision of Professor Zanino and Professor Dulla. The framework of my work is the decommissioning of the Enrico Fermi nuclear power plant. More in general, the aim is to develop a computational tool that evaluates the residual activation in supporting structures of the reactor, such as the reactor pressure vessel and the reactor vessel internals, in order to help determine the final radiological status of the structures and help the development of a decommissioning plan. In order to do this, a hybrid Monte Carlo / deterministic four-step scheme was developed, formed by different parts that I will be here briefly discussed. The first part is the calculation done using a Monte Carlo software, and it was necessary to evaluate the neutron source. So data from the reactor materials and the reactor geometries were put together inside a neutronic model that was used to calculate this neutron source. The neutron source was afterwards used in a second set of Monte Carlo simulations that were done in external source mode and with the help of variance reduction techniques, which are necessary to help the neutrons move towards the destination that we want them to reach. In this case, I was in particular interested in the thermal shield of the reactor because it's a component that was used only during the first operating cycle and then was removed from the reactor and was used for some measurements. So there were experimental data on this component, and I was interested in validating my model. Out of this set of simulation, we get neutron fluxes and spectra, which are used in the third step of the evaluation of the calculation, which is the deterministic part, in particular the activation calculation of the structures. And the fourth step, which is basically just the result validation, so comparing the values from my model with the values coming from the measurements. The model provided good results. In fact, it was quite good at predicting the residual activation of the structures. These are just some examples of what has been done. In this case, the comparison was done using the C/M ratio, which is basically just the calculated values of specific activity divided by the measured ones. And the closer the value to 1, the better the model. In this case, we can see that for these two isotopes, the predictions are quite satisfying. And here we have another example. This all led to a publication in Annals of Nuclear Energy, which is quite recent, it's from this year. Thank you for watching this video and have a nice day. Bye bye.